The Moscow Mining Academy was established in 1918. Thus this year it celebrates its century. It can be stated that the Geological Museum has existed in the Moscow Mining Academy since the very foundation. The first exhibits in the mineralogical cabinet of the Moscow Mining Academy were brought by the famous geologist Gapeev Alexander. His main scientific works are devoted to the study of the geological structure and industrial assessment of coal deposits of Donbass and Kuzbass. Alexander Gapeev was a professor at the Moscow Mining Academy after the Moscow Mining Institute since 1926. He brought the first samples from Hibin and they were used for studying rocks, minerals and ores. However, repeated reorganization of the university led to the loss of the museum's first collection. Its funds were partially moved to museums of other universities, partially lost. In the early 18th, it was decided to recreate the museum at the Moscow Mining Institute. The museum was created as a department of geology, headed by Ershov Vadim Viktorovich. He also organized and coordinated all the work of the museum creation. New collections were badged and purchased, special equipment and decoration were designed. In 1989, on the 1st of February, the museum was opened. To this event, many Moscow collectors brought their samples and collections. Also, to replenish the collection, teachers, staff and students of the Moscow Mining University donated their personal exhibits. 20 years after the opening of the first hall, the second one was opened at Moscow State Mining University. There, the original idea of the collection was developed. Countries and continents, an exposition around the world occupies most of the area. The significantly expanded collection from the former Soviet republics moved to the second hall, as well as samples of Moscow, Moscow region and adjacent territories within the Moscow synclines. The exposition minerals and historical materials were also added at the exhibition history page of mining in Russia. Besides, temporary exhibitions of geological and mineralogical subjects are located in large showcases. The museum stores samples of a mineral named after its founder, Ershov is a fairly rare mineral, silicate. This mineral has a greenish color, a small hardness, a density of 2.72 grams per cubic centimeter, glass shine. A distinctive feature of the museum is the novelty of the main exposition, where along with the classical systematic collection of mineral and rocks, regional collections across the territories of the European part of the Russian Federation, the Urals, Siberia and the Far East are also presented. The expositions introduce the new, rare and characteristical minerals of each region and their most important deposits. There are thematic exhibitions in the museum, for example, minerals discovered on the territory of the country, synthetic minerals, exposition dedicated to the names of minerals, gems. The exhibitions of new mineral samples, as well as the result of field, methodical and artistic works of the museum staff, are held regularly. An important place is occupied by educational and research work on the evaluation of collection, raw materials deposits, and the students' education using the expositions of Geological Museum. The excursions to the museum are organized for school children, students, and also for the visitors of different ages and professions. Within the framework of studying the geological cycle disciplines, students of the Mining Institute held practical classes at the Geological Museum. Students acquire the skills of diagnostic minerals and rocks, study the classification of minerals, the principles of crystal lattice structure, and other aspects of the properties and structure of minerals and rocks. In January 2018, the grand opening of the renovated hall of the Geological Museum, named after Professor Vadim Ershov, took place in the building of College of Mining of National University of Science and Technology MISIS, and was timed to the 100th anniversary of the Moscow Mining Academy. The Geological Museum, named after Ershov, is a pearl not only of the Mining Institute, but of the whole university. Following to the motto of our university, preserving traditions ahead of time, the transformation of the museum complex was begun, which includes the transition to the maximum use of interactive technologies, the original geometry of the exhibition space, and comfortable visual perception of the exposition. Now it is a large, bright space with interactive zones, with touch screens on walls and columns, where you can get information about interesting historical facts concerning geology and minerals, see presentations about various deposits, and also get information about expositions of geological and mineralogical museums of the world. The renewed museum is a full-fledged educational space with the possibility of holding thematic excursions. Its exposition is addressed to mining students who study geological disciplines, to employers that work in mining industry, and to all those who are interested in rocks. For example, among the unique collections of the museum are colored stones of the modern Moscow region, new and rare minerals of Khibina and Lavozera. Also, there are separate showcases dedicated to the minerals of the Urals. Today, the museum funds number more than 12,000 samples of minerals, rocks, and products made of stone-colored raw materials, of which more than 6,300 samples are in the main fund, including over 600 mineral species. It is important not only that the museum stores and presents its collections to visitors. The way how a museum does it is also an important point. The museum uses modern technologies that give the opportunity to visit the world technical museums without leaving the hall. Here, the original part of the exposition is collected, which represents the regional systematization of geological material and reflects the mineral resources base of Russian regions. Next to the sample of the main minerals and rocks are placed a remarkable collection of rare minerals and gems, for example, products from charoite, rhodonite, serpentine. You can see an amazing collection of malachite and its products not only from Russia and Kazakhstan deposits, but also abroad, including a sample from the Republic of Congo. One of the newly discovered minerals in human history in the 20th century is skarn. This sample is from skarn deposits of boron. It is used as an ornamental stone. Note the mineral of the reddish-pink color. This is rhodonite. The name of this mineral comes from the Greek word rhodon, which means rose. The presence of manganese in this mineral gives it a bright pink and black branching veins hydroxide, enrich its original design. Initially, the Soviet Union used it as a facing stone in particular and for the finishing of the Moscow metro. The decor of the station Mayakovskaya was used rhodonite from the Ural deposits. The blue mineral and its products are represented here. It is lazurite, mined in Afghanistan, Badakhshan, in Russia, southern Baikal region, Argentina, Chile, USA, Myanmar, Tajikistan, Pamir. Copies in Badakhshan are the oldest in the world. Afghan lapis lazuli from the field Sarisang has been found in the tombs of the pharaohs and the excavation of Troy. The Baikal lapis lazuli is not inferior in quality to Badakhshan. From it was supposed to build columns in one of the most famous cathedrals of Russia, St. Isaac's Cathedral. All interior decoration is decorated with columns from malachite and lazurite. On the shelves you can see many samples of various breeds. But pay attention on nothing mineral in my hand. Ordinary people do not even realize that one small change can make it precious or semi-precious stones. This mineral is called carant. This is an aluminium oxide, but just add a little of the chromium impurity and we get ruby. And if we add an admixture of iron and titan, then we get a sapphire. Also pay attention to the lilac stone charoite. Here it is. The only deposit in the world, charoite, Sirenievый камень, which is located in the northwestern part of the Aldan Shield, located at the junction of Yakutia and the Irkutsk region in the watershed of the river Chara and Toko. For the first time, clumps of violet mineral were found by the geologist Dietmar in 1948 during the geological survey. The total area of distribution of charoite rocks is about 10 square kilometers. Rock age is about 134 million years. With the discovery of charoite, there is a remarkable story. The discoverer of the deposit, Yuri Rogov, was sent by the government to a business trip abroad. There he went to the Mineralogical Museum of the Louvre, which claims to have a complete collection of all minerals of the earth, and having shown a plate of lilac rock. Asked to determine the mineral, the museum staff were forced to admit that they didn't have such a mineral and offered to sell the sample, but the Soviet geologist refused. Coal, a rock that was mined one of the first in the world. Coal consists mainly of carbon and is formed by the conversion of dead vegetation. Types of coal: anthracite, coal, lignite. The methods of coal mining depend on the depth of its occurrence. The development is the open way in the coal mines, when the coal seam depth of not more than 100 meters. Quite often, in such cases, when the dipping of the coal mine is further profitable, it is further profitable to develop a coal deposit by an underground method. A zest of the whole is a mini exhibition in a stone light that located in a specially kept room to the left to the entrance, curtains with thick curtains. Here in darkness we can watch the beauty of play of stone's light influenced by ultraviolet exposure. The luminescence that stops immediately after cessation of ultraviolet exposure is called fluorescence. And if a slow decay of luminescence measured in seconds, minutes or even hours is observed, then this phenomenon is called phosphorescence. Several bright stories related to the manifestation of luminescence are known in geology. This phenomenon was first described by the Italian alchemist Cacciarola in 1602. He tried to extract gold from the heavy spare barite and noticed that after calcination, barite acquires an amazing ability to store the sunbeams and then return them in the form of phosphorescence for several hours. In 1935, the Soviet geologist Smolyaninov for the first time discovered an ore deposit with the help of fluorescence lamp. He was examining samples of stone material brought from the town located in Tajikistan and noticed in these pieces a scheelite cluster, which is extremely difficult to detect with the naked eye.